much for coming here, listening to this talk. I'm from JP Morgan, and today I'll be talking to you about how we leverage LLMs to create merchant metadata that we then organize into a knowledge graph. So let's do it. Oh, nope, not that way. Okay, so even though a merchant knowledge graph can be used for multiple use cases, but just for the sake of kind of grounding our discussion here, I'm going to be very specific about one specific use case, and this is the merchant recommendation problem. Raise your hands if you all enjoy your, not just through Chase, I'm sure American Express have them too, but your credit card offers, like who's taking advantage? Yay, great, because it saves you money. So exactly, so at JP Morgan, we have credit cards, and as part of our offering is they're called Chase offers. And so we want to be able to recommend the right offers to you based on your transaction history. I need to learn to click but however, from a data science, machine learning perspective, this recommendation problem is really like, how do I identify similar and related merchants to recommend to you, right? And also, how do we get reliable information that's also cost effective? So for some of you guys who had just attended the Llama Index talk, the whole thing about knowledge agents, that's really kind of where we're going. And this is kind of a homegrown solution for now, but of course we're always evaluating new technology so that we can make our pipeline more robust. But essentially, keep in mind these two are the problems that we're dealing with. How do we recommend as well as do it in a cost-effective way? So let's just dig deeper. Like, what is the data I'm actually looking at? So those three are just some random currently available Chase offers that's available. And so Liquid IV, as you can see, I just showed you what a data scientist might actually get exposed to, and its description that looks like this. So sure, it does describe the company somewhat, but the description itself is very inconsistent, right? So Uber Eats it's very much like, oh, come order food on our platform. So it doesn't really talk too much about what their company's about. And then lastly, Shake Shack at least talks about some of the offering, which is pretty helpful. But the idea is that since large language models have been trained on so much data, we should be able to leverage them to get even more information than these descriptions. And so that's really where we're coming from. Now, on the other side, what do we know about our customers? Well, for those of you guys who use credit cards, this is probably very familiar to you. So unlike Amazon, where Amazon probably knows exactly what you bought, people like myself, we only get to see your transactions, where you bought them, and maybe like how much, along with the categories. So our machine learning team essentially is trying to use that information, the merchant name as well as the category, in order to infer, what your preferences are and what merchants we should recommend to you from the population of offers merchants. So our solution, as I've already kind of mentioned to you guys, we're using LLM to generate the metadata for these merchants and also using it to fact check. And then from the vetted information, these merchant metadata, then we build a knowledge graph. And so in terms of a framework, you can think of it as like in terms of agents, you can think of it as it's kind of a chain type of pipeline where we have name reconciliation first, because as you saw previously, for example, PayPal ChargePoint, it should just reconcile to ChargePoint. Or that Apple Pay, this last one, the Santa Cruz, that one is actually Santa Cruz Boardwalk. My daughter made that transaction, but we need to reconcile it to Santa Cruz Boardwalk, right? So as a result, name reconciliation is actually really important because it kind of brings it back to what is the noisy transaction name, bring it back to, what is the business true name that the LLM knows it by. And then therefore, then we generate metadata and then we verify. And then finally, we build a knowledge graph. And along the way, there's some twists and turns and multiple types of, agents that could come into play. But imagine this is the main pipeline. And so what I'm showing you right now is kind of like the inputs, outputs to the various blocks, which I'm now going to dig deeper with a concrete example. Okay, so with name reconciliation, and for the rest of this talk, I'm not allowed to show you guys the actual names. So the company names have been obfuscated, but I've obfuscated them in a way that you can still get the gist of what that business is doing. So imagine we have Yummy Chinese Express, except you order through Grubhub. So on your transaction, it actually has that Grubhub. So if we are to not use LLM, they might kind of get confused with, oh, maybe this is Grubhub. But no, it should reconcile to Yummy Chinese Express under food and drinks. And so when we do our metadata generation, currently we do have a fixed prompt because we're in a heavily regulated industry. As a result, our prompts have to be approved. But this is through various iterations of, LLM prompting itself, improving. And so this is the final response that we have products. And you might see that products is actually categorized to the so-called industry. So orange chicken falls under food. So unfortunately, this example is all food. But in other examples, such as, again, I'm not allowed to say company names, but if you can imagine a conglomerate that has multiple lines of businesses, perhaps they might have different categories. So you can read it here. So we're also getting services, competitors, even target customers, and then a nice description that tries to summarize everything that's above. I want to say that from the get-go, our thinking is that we want very structured type of responses because we're chaining them. And so you can imagine even after this generation, we can also have an agent to just kind of double check whenever it doesn't load properly as a JSON. Now, I've kind of taken away some of the metadata so that we can get deep into like what exactly this metadata verification bit is about. So I would take this JSON, and then what we do is that we would then transform it into these triples. And this triple is kind of, for those of you guys who work with knowledge graphs, this should be very familiar to you because generally these triples defines the head node and then the edge and then the tail node. However, we also use these triples to formulate what's called claims. And claims are really just part of verification. So for those of you guys who do any type of fact checking, usually you take an atomic fact, or in some community could be called claims as well. So I took the triplets right here. So the first one, Yummy Chinese Express offers orange chicken, the first line, and now I've made them into sentences. So triples into claims, and then we would, so in terms of fetching evidence, you can either do it through a RAG system if you already have the documents kind of stored away, or if you can also call an external knowledge APIs, SERP API, or various other Perplexity, then you can fetch, you can use the response, and that essentially formulates your so-called documents right there. So there, we see that we have that paragraph that talks about that specific restaurants offerings. So I've kind of color coded. I've kind of highlighted using the same colors the same. So you can see that at least the first one, there's very strong evidence that those are the true offerings. However, spring roll isn't one of them. So what the next step in this verification is that in general, we would take the claims and then as well as the evidence that was retrieved, either again through RAG or some other knowledge API, formulate that into a verification claim for LLM-as-a-Judge as an initial pass. Because we're talking about in a 90-day period, we have millions of transactions from the credit card transaction histories, but we might generally have within like in the 10,000s of offers. So we're talking about this as kind of large scale. So as a result, we always want to use LLM-as-a-Judge whenever feasible. And then, for example, and even when we prompt for the verification, we actually prompt for uncertainty as well. And we use we use these uncertainties in order to kind of triage. Hey, is it certain enough so that we don't need the human in the loop? Or if it's a medium certainty, then we would generally pass it over to the human in the loop for a second look. And then finally, imagine after this step, we now have all of our green, our vetted claims, which again, really just maps nicely back into triples. Then the triple itself now are ready for ingestion into a knowledge graph. And so I kind of hid this from you until this point. Actually, when I designed the prompt, I kind of already had an idea for the schema because since this talk is about how do you have metadata and work it into a knowledge graph, so I actually use the schema to help motivate how I designed the prompt. I mean, that's one way of doing it, but however, you can also do it, you can go through the prompt and then based on what the LLM tells you, you can easily use things like LLM graph transformer in order to suggest a schema for you, and then you can refine accordingly. So those are the schemas. That's the graph schema I'm sticking with. And then so this is Yummy Chinese Express's contribution to our entire merchant graph. So you can see that in the yellow, we have the customers, right? So remember, yellow are the customer nodes. And then the blue are the products. The pink, I apologize in advance for folks that are colorblind. But hopefully you kind of can follow that the pink are the products. And then the orange are the, again, those are obfuscated names. They're not real names. But everything else is true, is factual. And so this is a knowledge graph. Now, how do we evaluate all this? So the way we evaluate it is that, imagine we have all of the metadata. Again, we talked about there are two populations, right? The first population are the offers. So those are the ones you pulled up on your app and you can activate. And then the green are the transaction merchants, which means they're the merchants that you've been shopping at. And so from those, we get the metadata from them. We would embed them. And then in this case, I decide to, based on an offer, so using one offer merchant, I'm going to then try to fetch what are the most similar merchants from the transaction merchant population. Again, it's symmetric, so you can always do it the other way around. I just decided to do it this way. And then apply LLM-as-a-Judge, then try to get some performance numbers. So in terms of embeddings, we have the baseline, which is not using any of the LLM-generated metadata. And then the second one, Metadata, is just taking the description from the metadata that's generated and then just putting it through ADA. And then TransE and complexity, those are knowledge graph types of embeddings. And so you see, these are the Violin plots for it. In general, there are two different types because, again, we use LLM-as-a-Judge. I asked it to tell me based on what I've retrieved, can you tell me whether it's highly relevant, medium relevant, low, or I don't know. And so if you only take what the LLMs say are highly relevant, those are the orange Violin plots. If you're taking both high and medium, then those are the green ones. And what you should take away from this is the higher, I guess, the tip of the violin is, the better. And so we see that the Metadata as well as TransE are generally better than the baseline and the complex E. And so because of time, I probably need to go soon, but here are some qualitative results. Shabu Shabu Restaurant is a restaurant where people cook things in a pot. It's kind of yummy. I like it. Again, this is kind of random, but Lisa is more of a luxury mattress type of company. So you see across the three, we see that these are some qualitative results that show how well it performs. Now, takeaways. So this use case had accomplished is that we generated a metadata pipeline that created metadata, but we also vet them in a kind of responsible way, and then we organize them into a knowledge graph. And so, yeah, I guess folks can kind of read what I've used LLMs for, as well as knowledge graphs. And in terms of generating insights for merchant recommendation, so those are the last few slides I showed you. We also embed them in different ways using just the text and also compare against knowledge graph type of embeddings. And we saw that Metadata and TransE, so anything with meta means it did use the metadata that we talked about, the 4-step approach. And it did do better than baseline. So that means this was a success. And what I want to say is metadata is actually about 1,500 in terms of the dimension, but TransE, we were using about 150. And all these dimensions were actually hyperparameter swept. So they've been optimized already. And so, going forward, I feel that we could use either or, but because I love graphs, I will probably use TransE or more the knowledge graph type of embedding. And now in the blue and purple, that's my own opinion. Having developed this over, I want to say I think I really seriously super worked on this in like December, starting last December. I feel that generating metadata using LLM, like that is the easy part because there's just so much tools out there. And even the knowledge graph part, organizing it as well as training embeddings, if you kind of dedicate the time to learning, the tools out there, it's also not as bad. It might be more involved in a metadata generation because you might need to, do distributed training or whatnot. But what to me personally, in my personal journey, to be the most kind of eye-opening and, taking a lot more brain cells to figure things right is really the metadata verification. As you can imagine, you could have multiple data sources, in which case you might need agents to figure out which source to pull from. And even that, we also have the LLM-as-a-Judge. We could use multiple LLMs, in which case we need to figure out which LLM might be more, expert in certain areas. So there's actually a lot of loops over in the metadata verification. So I just want to at least share a bit that, to me, don't shy away from knowledge graphs because they're actually they're wonderful in terms of organizing structured data, and they're not too bad to work with. And with that, I've been told to wrap up, and I'm happy to take questions.